Electrolysis and its mechanism. This is today's lesson. Let us see the matter in detail. Electrolysis and its mechanism. First of all, let us try to know what is electrolysis. Sodium chloride. Solution of sodium chloride. An electrolytic solution of sodium chloride through which electricity is passed. Then sodium chloride undergoes decomposition to form solid sodium and chlorine gas. This decomposition reaction is known as electrolysis by passing electricity. Definition of electrolysis is the decomposition reaction of an electrolytic solution or decomposition reaction of an electrolyte in its solution or in its molten state liquid by passing electricity through it is known as electrolysis. Again, the decomposition reaction of an electrolyte in its solution or in its molten state by passing electricity through it is known as electrolysis. What is the application of electrolysis? Electrolysis is applied to produce compounds from one compound by passing electricity. This is the application of electrolysis. Now, let us see mechanism of electrolysis. Let us consider this is a vessel. Glass vessel or ceramic ware, glass ware or ceramic ware, in which solution of an electrolyte is taken. Suppose this is solution of sodium chloride, electrolytic solution of sodium chloride. In this solution, two metallic strips are immersed. Metallic strips are submerged in this solution. Metallic strip of inert metal like platinum. Inert metal is used here. Otherwise, this might react with this solution, with this electrolyte. For this reason, inert metal is used as electrodes here. So the question is, why inert metal is used here? The answer is to avoid unexpected reactions. Here, metallic strips of inert metal is used. Now, these two metallic strips are connected with wire with a dry cell, external electrical source. This is dry cell. This is positive end. This is negative end. This dry cell is represented here by two lines. Long line indicates positive end of dry cell and short line indicates negative end of dry cell. So this is positive end of dry cell, this is negative end of dry cell. Now, this metallic strip is positive in charge because this is connected to positive end of the cell. Similarly, this metallic strip is negative in charge because this is connected to negative end of the cell. This metallic bar is positive in charge because this is connected to positive end of the cell, and this metallic bar is negative in charge because this is connected to the negative end of the cell. Now, the circuit is complete in which this is positive in charge and this metallic bar is negative in charge, and solution contains positively charged ions and negatively charged ions. At this moment, negatively charged ions will migrate towards positively charged bar because of this positive negative attraction. That is, here negatively charged ions will move towards positively charged bar because this is electronically rich and this is electronically deficient. Now, here this reaction will occur. Negatively charged ion in solution will donate electron to the electronically deficient metallic bar to form chlorine atom. We know chlorine cannot exist as atomic form. Another chloride ion will donate electron to form chlorine atom. Now, these two chlorine atoms combine together to form chlorine gas, which is observed here as bubbles of chlorine gas. Here, removal of electron occurs. We know that removal of electron is oxidation reaction. So, these oxidation reactions occur at this metallic bar, at the metallic bar with positive charge. So, this is called anode. What is the definition of anode? The metallic bar in electrolytic cell. The metallic bar in electrolytic cell in which oxidation occurs, that is called anode. This is definition of anode. So, we can write here anodic reactions or reactions at anode. Now, let us see what reactions occur at cathode. This is positive in charge, electronically deficient, and this is negative in charge, electronically rich. Sodium ion will move towards this metallic bar, which is negative in charge, and there sodium ion will receive electron to form sodium metal solid. In this way, sodium deposits on the surface of this metallic bar. Now, here, this is addition reaction of electrons. Addition of electron is known as reduction reaction. simply reduction. That is, the metallic bar which is negative in charge, there reduction reactions occur. Here reduction reaction occurs. The metallic strip in which reduction reaction occurs, that is called cathode. Definition of cathode: the metallic strip in electrolytic cell in which reduction reaction occurs, that is called cathode. So we can say that here reaction at cathode or cathodic reaction. This is reaction at anode or anodic reaction, reaction at cathode or cathodic reaction. This is anode where oxidation occurs. This is cathode where reduction occurs. Cathode and anode and cathode are together called electrodes. What is electrode? Electrode is defined as the electrical conductor that makes an electrical conduct with non-metallic part in the circuit. So electrodes that make electrical conduct with the non-metallic part of the circuit. So electrodes. Now let us write complete reactions. Chloride ions, 2 chloride ions that convert to chlorine gas by removal of two electrons, and here sodium ion will receive electron to form sodium solid. That is here sodium ion and 2 chloride ion. Electricity. This is source of electricity, external source of electricity, which is passed through the solution of an electrolyte. Then this electrolyte converts to sodium ion and chlorine gas. Decomposition reaction. The chemical decomposition of an electrolyte in its solution or in its molten state, which occurs due to the passing of electricity through it, is known as electrolysis, balanced reaction. Here we can balance this reaction in this way. Sodium chloride and electrolyte. This is electrolysis and this is the mechanism of electrolysis. Electrolysis is carried out in electrolytic cell. Electrolytic cell, an electric cell in which external electrical power is used to force a chemical reaction, and external energy is used to occur a chemical reaction. This is electrolytic cell. Electrolysis is carried out in aqueous solution of an electrolyte, or at least it should be melted. Electrolysis is carried out in the solution of electrolyte or in the molten state of electrolyte. This is because here ions are moving towards anode and towards cathode. If we use solid sodium chloride, then ions cannot move towards anode and towards cathode, and then no reaction will occur due to the lack of movement of the ions. That is why it should be aqueous solution or at least molten state. Electrolysis and its mechanism. Thanks for watching.